Hello, this is a quick start tutorial for Mosaic Inspector. This tutorial covers the minimum basics of getting Mosaic Inspector running in your project. It does not touch more complex features of Mosaic Inspector, which are further covered in documentation. It assumes the minimal knowledge of Unity and Rapid IOC. In this tutorial, we will create a three-dimensional box in the basic Mosaic Inspector panel that reflects its position and rotation. We will also add feedback control from Mosaic Inspector. So the first thing you want to do is open Unity and create a new project. In this case, I already done so. I called it a My Tutorial. The next step is to import Mosaic Inspector Unity package. Typically, you would do this from Asset Store, but in my case, I have it on my hard drive. So let's import it. In our case, we don't need the entire package. We can actually disable certain folders that we're not going to use in this tutorial. And these folders are specifically located under scenes. It includes, if we inspect for it, it includes Mosaic Creator and Mosaic Demo, and will not be covered in this tutorial. So click Import. Once this is done and Mosaic Inspector is added to your project, we can start working on creating the scene. So the first thing to do is go to Scene Hierarchy in the upper left corner and create a new game object. We will call it Scene Object, or rather just Scene. This is going to be our root game object that everything within the scene will be parented to. You can read more about this in Rapid IOC documentation. But for now, let's continue on our tutorial. So let's create another game object, and this time it will be parented to scene, and it's going to be a 3D cube. So if we look right now in our game view, it would look something like this. Next, adjust the camera settings. Since we are going to be moving this object on a 2D plane, set projection to orthographic and set projection size to 10. And we don't really need a skybox, so change background to solid color. Finally, the last step before adding Mosaic Inspector is to add event system and a standalone input module. This will help us interact with both the cube and Mosaic Inspector using our mouse and keyboard. So select Scene Object, click Add Component, and add Event System, add another component, standalone, input module. We don't need to change any properties here. Our scene setup is now complete. Let's add some scripts. In your Scenes folder, in the project window, create a new folder called Scripts. And finally cube model. Add sample scene view to the scene object. and cube view to the cube object. Sample scene view will contain the scene setup code. Cube view is our cube controller, and cube model is the data layer containing the cube parameters. Now let's write some actual code. Open cube model in the editor of your choice. In my case, it's Visual Studio. Cube model is a non-monobehavior class. So we can remove this dependency, and it will just contain two simple parameters. It will contain the rotation of the cube, so we can do public float rotation, and it will contain the position, which we will represent with a vector 2, since the cube is moving on a 2D plane. And we don't need those namespaces since we're not using them. Next, let's open sample scene view. This script is going to be a little bit more complex than cube model. Its responsibility is to set up the scene, install the Mosaic inspector, and create all the necessary bindings. The first thing we should do is change our sample scene view's base class to main scene view. This denotes that sample scene view is our first scene that is loaded in this project. I will not go into details how it works and why this is important, but you can read more on this in Rapid IOC documentation. Step number 2 is to load Mosaic Inspector as soon as sample scene view is loaded. Since Mosaic Inspector is on a different scene, we need to tell our sample scene view to load that scene as soon as a sample scene view is loaded. Thankfully, Rapid IOC has an attribute called scene relationship attribute, which takes two parameters. The first parameter is a scene type. So in our case, it's going to be type of Mosaic Inspector scene view. And the second parameter is its relationship to the scene. In our case, the relationship is to include the scene. Next, we need to get access to Mosaic Inspector. To do this, we will inject Mosaic Interface property. So all we need to do is to create this property here, Mosaic. It has to have both get and set, and it has to be public. And most importantly, it has to have a inject attribute. So what this does is, as soon as sample scene view is loaded, it will load Mosaic Inspector scene, which will bind Mosaic interface, and we will have access to its instance within sample scene view instance. Now for the fun part. Let's create the actual inspector. So we are not going to need a update function. Instead, let's rename that to install inspector. And here we will construct our inspector hierarchy. To do this, we will call install shard function on the Mosaic instance. So mosaic.install shard. In install shard properties, we specify the type of shard to install. Shards are installed in order of parent, then child. So the first shard we would install is the root layout of our inspector. To install shards, we supply the install shard function with instance of layout model. Layout model is a class which contains the descriptors that are used to create the shard view. So in case of root layout, we are going to create the layout model describing it. So the first parameter that we do need is the name of the shard, which is going to be root layout. The second very important parameter also is the shard prefab. Shard prefab determines which prefab to choose from the prefab cache to instantiate. And in case of the layouts, we already have some constants defined. So all we need to do is specify past that specific constant. So we can do layout model, and we specify layout horizontal because everything is going to be positioned in a horizontal manner. And last but not least is child alignment, which determines how are the children shards positioned within this parent shard. So in our case, we will just align them to the right. The next shard we're going to install is going to be another layout, but in this case it's going to be our side layout, which will reposition children within on a sidebar, basically. What's convenient about Mosaic Inspector is you can actually chain install shard function, because install shard function itself returns the iShard instance of the shard that was just installed. We can just do this. We can do install shard again, and this shard will be installed as a child to the previous shard. So for the side layout, we're going to do exactly the same thing as for the root layout. New layout model. In this case, we are going to call it side layout. For the shard prefab, it doesn't really matter, but we also can use layout model horizontal. By the way, all those constants are defined within the specific models of the shards themselves. So in case of layouts, you can just go to layout model and see all the constants defined here for the prefab. So we have horizontal and vertical. But of course, if you ever decide to create shards of your own, you'll have to specify shard prefabs of your custom shards. And the final shard we want to install is the window view. The window view will contain the cube model that we actually want to reflect in the Mosaic Inspector. So we do exactly the same thing. Install shard. We specify new layout model. Sorry, new window model. Because this time we are not installing a layout, we're actually installing a window. Let's call it cube properties. As a shard prefab, we are going to use the default window prefab, which is a scrolling window. So again, we can do window model dot, and we can just select the predefined prefab constant. And window model can contain only a single element, which is in our case is going to be our cube model. And the way we can do this is specify shards collection, and here we would actually create a new element model. And it has a static function called create, where we can pass the instance that we want to reflect. But we haven't done this yet, so let's create our cube model first. So again, we will probably want to inject it, because cube model needs to be accessed not only by the sample scene view, but by cube view and Mosaic inspector. So let's inject property cube model, and I'll just call it cube model. Again, don't forget both public getters and setters. Now, while this model is injected, it hasn't actually been binded anywhere. So we also want to bind it. And the way to do this with the any class deriving from the scene view is to override the map bindings function. So we can do this. Override map bindings. Do not delete the base map bindings call, because that is important. And to bind something, we will call rapid.bind. In our case, we actually want to create an instance of cube model. And the way to do this is to call the generic bind function, where you specify the type of the instance you want to create. So in our case, we would call wrap bind with the cube model type. And notice how I have not specified any parameters within the bind function. If we would specify some sort of a string, it would bind that cube model to that specific context, which, if you follow the rapid IOC documentation, every scene has its own context. But cube model needs to be accessible from different scenes, both from sample scene and from Mosaic inspector scene. So if you do not pass any context name as a parameter, it will bind it to global context, accessible by all scenes in the project. And finally, we actually need to call the install inspector function. This has to be done from the start function. The reason for it is that if you would call this from the awake function, the Mosaic inspector is not installed at that point. Calling install inspector from the start function guarantees that everything within Mosaic inspector is loaded and ready to be used. Finally, we can remove namespaces we're not using, save the file, and let's see what it looks like. However, before we run the project, we need to include the Mosaic inspector scene in the build settings. So if we open build settings, we navigate to Mosaic inspector folder, Mosaic inspector, and here we see the Mosaic inspector scene, which we can actually drag and drop within the scenes to build. Now, if I press play, our Mosaic inspector will show up. But as you may notice, it's not positioned correctly. We've created a separate layout called side layout, and we wanted to position our Mosaic inspector to the right side of the screen. And we forgot one important attribute for side layout. And the name of this attribute is shard alignment. So let's specify it right now. So there are two properties that we need to set. The first one is the height. In this case, we're going to use flexible height and set it to 1. And the second property is the width. And for that, we will use preferred width. If you are somewhat familiar with Unity UI, you will notice that this is very much similar to the layout element parameters. and it functions very much the same. So if we save this file now and run it in Unity, our cube properties is positioned correctly on the right side of the screen. Modifying these values currently does nothing because cube model is not connected to the actual cube view. So for example, if I set rotation to 45, nothing happens. This is because we need to assign the cube view to the cube, assign the cube model to the cube view. And we haven't actually written any code for cube view, which is what we are going to do next. So in your scripts folder, in your scenes scripts folder, open the cube view, and let's write some code for that. Our cube view is going to inherit from component model view. And as a generic parameter, it's going to accept the cube model type. Now, if we inspect component model view, we can see that it provides the model property. In our case, it's going to be cube model type. So all we need to do is a way to assign this model. And for that, we can use rapid IOC injection. To do that, we are going to override this property. And the only thing we need to do here is to add the inject attribute. So what is going to happen is as soon as CubeView is loaded, it will search for the cube model in its local and global context. And since we bind the cube model in sample system view to the global context over here, it will find it and assign it to this cube view. So this is all the code that we need to assign this model. Once the model is assigned, it will call the update model function within the component model view. So if we examine component model view, in the model setter, we can see that it calls update model, which is marked as protected virtual, and it does not have any body. The intention is that this function will be overridden in a derived class. So let's do just that. We don't actually need the update and start functions in our cube view, so I'm going to delete them, and instead I will override update model. Update model will update the cube view's position and cube view's rotation based on the values in the cube model. And the best way to do this is to create two separate functions. Later you will see why. So first let's create update position function. Our update position will set the transform position to that which is indicated within the cube model. And if you examine cube model, you notice that the position is a vector 2 instead of vector 3. This is because we only care about the 2D plane. So since transform contains a three-dimensional position, we will just create a new vector 3 and assign model's position x and model's position y. And 0 for the z-plane, since we're not moving along subplane. And for the update rotation function, the same thing. Unity provides a convenient quaternion angle axis function, which rotates the object around the axis specified. So in our case, we will have model rotation as the angle and the forward axis as the axis to rotate around. And both of these functions should be called from the update model. So what that means is as soon as model is assigned to cube view with values that are different from that of the transform of the cube view, they will be updated to the cube model's value. Next step is one of the most important steps in this tutorial. We need to connect cube view to Mosaic inspector so that when we modify a value within Mosaic inspector, cube view would be updated. And to do that, we are going to use a signal called notify field change signal. Let's call it notify field change signal. And we are going to inject it in similar fashion as we did with the model. That signal is binded within Mosaic inspector scene, so we don't need to worry about binding it. Since we actually want to listen to the signal, we also need to create a listener. And it is very important to name our listener correctly. So if you read Rapid IOC documentation, any class deriving from the view base class will try to automatically bind any injected signals to listeners based on their naming pattern and the parameter types. So if we would create a function called on notify field change, and we will specify the parameter type that is the same as passed by notify field change signal, which is notify field change model. And of course, it has to be void return type. This listener would be automatically connected to the notify field change signal. So notice how the naming pattern works. We have to append the on prefix and remove the signal suffix. One thing to note is that notify field change signal is dispatched whenever any value within Mosaic inspector is modified. This means that oftentimes we will receive this signal when something is modified that we don't care about. So it is important to filter out all the unnecessary information. And to do that, we are going to place several if statements within our on notify field change listener. If we examine notify field change model, we can see that it contains three fields. The first field is the dispatcher. Dispatcher is the instance of an object which dispatched this signal. In our case, it's going to be Mosaic inspector element, because we modified something within Mosaic inspector. The second is the reference type, or the class which owns the field that was modified. So in our specific case, it is going to be cube model. And finally, a name or a list, an array of field names that were modified. This allows us to filter out specific fields that need to be updated. So going back to our cube view, we can start writing code to filter out unnecessary notify field change signal dispatches. The first thing we want to check is whether the dispatcher instance is different from the QView instance. What this does is check that somebody else dispatched the signal and not the QView itself. Otherwise, we are going to be unnecessarily updating a field that has already been updated by the QView. And to do this, we are going to use the reference equals function. And we are going to compare model dispatcher instance to the listening QView instance, which is going to be just this pointer. So in case dispatcher is this QView instance, we do not want to proceed. We can return here. Next check that we can do is verify that the model that is being updated is our instance of cube model. Again, we can use reference equals model value and check that against our model. So in this case, we actually do want to proceed. And it's best to just reverse this and return. So this means if the model is different from our cube model, we do not care about it. So if we got this far and the code has not returned yet, we are guaranteed that something within the cube model was updated. And since cube model contains only two fields, rotation and position, we can check which field was updated and update our cube view based on that. So what we're going to do is check which fields were updated within our notify field change model. To do this, we are going to use model fields contains function. And we are going to check the name of the field. If it's equal to position, we are going to update position. If it's equal to rotation, we are going to update rotation. Notice how we do not need to specify the position or rotation arguments. This is because the model instance was already updated by Mosaic Inspector. All we need to do is synchronize our cube view to the model. So let's save the file and see how it works in Unity. Let's set rotation to 45 degrees. And as you can see, the cube has rotated by 45 degrees. Let's try to set position to something like 5. All right, cube view moved by 5. Minus 5, 2, minus 2. So as you notice, as soon as we update something within Mosaic Inspector, the cube moves on the screen. But what if we want to update Mosaic Inspector whenever cube view is moved or rotated from the outside? To do that, we are going to implement drag handler within our cube view and have it update Mosaic Inspector in real time whenever we drag the cube around the screen. Let's go back to our source code. And let's have our QView implement drag handler interface. Drag handler requires us to have a onDrag function. Here we will add the code that interacts with the cube and updates or notifies Mosaic Inspector that the cube view position or rotation has changed. So I'm going to add the following code. Screen to world. So we find the position according to our mouse cursor within the world coordinates with the cube view. And we will update our we will actually update our model rotation and model position instead of cube view transform. And I'm going to add a check if we want to rotate or update based on holding down the left shift key. So if key code, or rather input key code left shift. So if we are holding down the left shift key, input get key, then in this case we actually want to rotate the cube. And I'm just using the x-axis for the rotation. We are updating rotation here. So we are calling update rotation, which would update the transform rotation here. And now the important part is to notify Mosaic Inspector that rotation has been updated. And for that, again, we can refer to notify field change signal, which we already have injected previously. So we are just going to dispatch it. And in our case, the dispatcher is going to be this, which is our instance of QView. The value is going to be model. And the field name is going to be rotation. If shift key is not pressed, we are going to update position. Again, update position and notify Mosaic Inspector that position has been updated. So if you notice that the dispatcher comes into play in our own notify field change signal listener. So if the QView instance is dispatching this model, it will still receive notify field change signal, but it will exit on the first check if reference equals model dispatcher and this. My bad, this should be actually update position, not update rotation. Save the code and see what it looks like in Unity. So if we press play right now, and apparently dragging is not working. This is because we forgot to attach physics recaster to our camera game object. So select main camera in the hierarchy, add component, physics recaster. Already have it selected here. And let's press play again. And now we can drag the cube around the screen, and Mosaic Inspector is updated in real time. If we hold down the left shift key, we can rotate the cube, and the rotation is updated. And if we were to update rotation from here, again, position. So this basically demonstrates the two-way feedback with Mosaic Inspector and the cube view. Now, for the final part of this tutorial, let's add a reset button to Mosaic Inspector. And this reset button will reset the cube's position and rotation to 0. To do this, let's go back to our source code, open cube model, and add public signal reset, and assign it to a new instance of the signal. So Mosaic Inspector will interpret the reset field as a button. So if I were to save cube model right now and press play in Unity, we are going to see the reset button. But this button is not connected to anything, so nothing happens. Let's connect it to the cube view. Go back to the source code, open cube view. In the update model function, we are going to connect the reset signal to a listener. So let's first actually add the listener itself. It's going to be a private function called reset. And it's going to assign position and rotation to 0. Vector to 0. It's going to update our transforms by calling the update position and update rotation functions. And finally, it's going to notify Mosaic Inspector that the both position and rotation were updated. To do that, we can actually copy notify field change signal to spatch function. But in this case, we want to specify both position and rotation fields. So instead, we can do something like this. And we want to connect the reset function to our reset listener from the cube model. Add command reset. Now this is not perfect because update model may be called more than once, but for this tutorial I'll just leave it as is. If we save it here and run Unity, let's move the cube somewhere on the screen, press reset, and it resets to the 0 position. This is the end of this tutorial, and hopefully I've demonstrated enough of the basic aspects of Mosaic Inspector to get you started on using it in your project. To learn more about more advanced features of Mosaic Inspector, such as Mosaic Creator, element drilling, displaying collections, and creating custom shard types, refer to Mosaic documentation. Thank you for watching.